Okay, so. All right, so what we're doing today is something called okay. Now, last week, when I said we were talking about thinner replacement, thinner replacement is a metal plus a salt. And then the metal might undergo oxidation, may not, depending on where it is in relation on the reactivity chart. Remember, if the metal's higher than the salt, the reaction goes. Period. Okay, double replacement reactions are a salt plus a salt. No metals involved at all. Okay, so an example of that would be silver nitrate plus sodium chloride. Both of those are salts. Ionic salts. Bless you. Okay, so I want to review a few things on the periodic table. Because these solubility rules, some of them are, they talk about groups and stuff. I just want to make sure we're all the same page regarding the periodic table. Now, we talked about this quite a while ago. So just as a refresher, periodic table has columns in it and it has rows. The columns, some of them, I asked you to know, there are 4 of them. There's the alkali metals, there's the alkali earth metals, halogens, and noble gases. Those are the 4 main ones. All of them have names, but rarely those names are ever used. The only time I saw the names is teaching chemistry. In use, no one uses them. Okay, so, and remember within the groups, the reason why they're named is because the chemistry within that group is the same. So if something, for example, beryllium forms a +2 ion, so does magnesium, calcium, strontium, barium, radium. All of those form +2 ions. Okay, we're going to learn about that towards the end of the semester, why that's so. Okay, so remember groups. So whenever the solubility rules mention everything in this group is soluble. For example, they'll say everything in group 1 is soluble. Never forms a solid. But you have to know what a group is before that makes any sense. Okay, and in the back of your lab packet, you'll see there's electrolytes, and then you'll see the solubility rules. Okay, so let's look at these solubility rules. It says compounds of the group 1, and it lists the elements, lithium, sodium, potassium, etc., or ammonia, NH4, are soluble all the time. No exceptions. That means if you put sodium with something else, it's always going to be soluble. Its solvating force is very strong. Nitrates, chlorates, perchlorates, acetates are also soluble all the time. Now, number 3, it says chlorides, bromides, and iodines are soluble except with silver, lead, and mercury. Except. Okay. Okay. So anyway, that's how to interpret that stuff. Okay. Now, what I've done is I've put together a table. That summarizes these rules. So there are a black square and there are white squares. If it's a black square, that means it forms a solid. White, yellow, maroon. If it's a white square, nothing happens. It stays soluble. So let's look now at this here. Okay, we've got those are the ions taken apart. So if we have a bucket or a beaker of silver nitrate, and we have a beaker full of sodium chloride, and we pour this into that, does anything happen? So on the left here, this is colorless. And so is this. When we put them together, we have two new combinations. We have silver and chloride. And sodium nitrate. So the question is, do they still say clear and colorless? Or does something happen like a solid forms? That's where you need your rules. So, sodium Na plus here, right here, is always soluble. Notice this column here is white all the way down. Thank you. Nitrate is white all the way across.
Oh, that thing. Yeah, I know.
On one. They have a, I agree. I don't have access to a copy machine anymore. So you know how I copy things? At City.
Oh, I don't know. I'm gonna take a picture of it.
It's in Canvas.
Mine is 5 minutes.
Okay, so I'm going to stop this and show you in Canvas where it's located. No. The last page of the lab packet has got the rules, but not the chart that I put together. I'm going to say, if you want to use the chart for today's lab, just pull it up on your phone or your laptop or a tablet. Under Files, then do a search of solubility. Solubility chart, Table. You want the table. Okay. Now, the problem is, this is a prep class for 1A or 2A or 3A. None of those teachers have seen my table. I did this to simplify the rule, because it's visual now, instead of trying to figure out. So,
Say, take this into that class and it'll be.
it will. The problem is, you won't be able to use this on a test. See, my tests, I give it to you, but. All right, anyway, that's where it's located. Just do a search on solubility. All right. So we also have, here it is up close. So when we mix these together, we have the new combination. The new combination is this. So question now is, what happens with that? Does that form a solid black square, yes or no? Well, first of all, sodium is always white. Nitrate is always white, so that does not form a solid. So that stays clear and colorless. What about the silver chloride? Okay, well, here's silver. Silver is both white and black. And here's chloride. So silver chloride forms a solid. I'm going to put an S there. The sodium nitrate doesn't form a solid. It stays as dissolved in solution or aqueous. Did you get a haircut? How to interrupt one's lecture? Come in with shorter hair.
So,
Huh? Is that rain on your? Is that rain on your?
Yeah, and I dropped my phone in the rack, took me about while I'm finding it.
Okay, so the sodium chloride now is aqueous. And so is the silver nitrate. Now the rule will tell you this, as well as the table. And I made the table from the rule. Okay, does everyone see how I ended up with silver chloride being S and not AQ? Where the two merge together, it's black. Black means solid. If they come together and the merging is white, that means it stays in solution. Okay, so if the solution has no color, it'll stay colorless and clear. It's got to be clear though. A murky solution, that means it's a solid in there. That's what makes it murky. Now, let me give you a nice exception. What color is milk?
White.
White. Does that mean there's a white solid in there? No. Milk has got fat dissolved in it. And tiny, tiny, tiny droplets. And when the light hits the tiny droplets, it scatters and you see white. But it's not because it's a solid. Catch it. Same thing. There's a number of things that appear like there's a solid, except our lab today. That'll be either black or white, so to speak. Okay, so when you're doing double replacement reactions, first thing is to figure out what's going on. That's what we just did, using the table or the rules. The next thing is you need to write something called, if something happens, you have to write something down called a net ionic equation. So this is called the molecular equation. That's the first thing to do. Now, the second thing to do is we're going to split everything up. And that's called a total ionic equation. And then the third thing is a net ionic equation. And sometimes you have a net ionic equation, sometimes you don't. If nothing happens when you put them together, you have no net ionic equation. Only if you see a solid color change. In our lab here, it's going to be a solid, but if you see a color change, there's a reason for the color change. Okay, now we are going to do this one and this one. So we've already done the molecular equation. Make sure it's balanced. Remember, always balance equations. Always. Assume the equation I give you is not balanced. You've got to check it. That's pretty true on any chemistry class. They will always give you just the plain old equation, not balanced at all. And it's your job to balance it. Okay, what about this net ionic equation? So we just shown that we have a solid form. That means we have a net ionic equation. Okay, so what formed the solid? The solid is silver chloride. What was used to form silver chloride? Two things. What are the two things used to form silver chloride? Silver and chloride. So that's the net ionic equation. And that is your dry lab today. Net ionic equation. Now, because we have crappy weather today, you're going to do the dry lab at home. I want you to do the wet lab here and then go home, because some of you live in areas where it easily get washed out. And so, all right. Okay, so does that make sense? And we're not going to focus on the total ionic equation. You're going to get that big time in 1A and 2A. And I want to make sure you understand the solubility rules or table and how to write a net ionic equation and a balanced molecular equation. Okay, now this is a pretty simple one. Does this make sense? That's fine. But you could follow me though, right? Okay. That's the first step. Gotta follow me. Can't follow me, well, sorry. All right, so okay, so let's do another one. Let's do now again, remember when I write AQ, that means aqueous. That means there's no solid in there. It's colorless, clear. And let's throw in okay, so we have a solution of sodium sulfate, ferric nitrate. Dump them together. So that means we have a new combination. One combination is sodium nitrate. And the other combination is does everyone see where I got the new combinations? Just swap the cations. This cation goes there. And this goes here. That's where the double replacement comes into play. Sometimes it's called double displacement also. Okay, so the question is, the sodium nitrate, remember the first one, sodium, all sodium compounds are soluble. That means that automatically becomes AQ. So the AQs are soluble. What about FeSO4? Look on here. What about nitrates? See, nitrates also are all white. That means they do not form solids. Ferric sulfate. Okay, let's find the sulfate on the left. Here's sulfate. And where's iron? Iron is right here. So does that form a solid? It's white. That means it's an AQ. So do we have a net ionic equation? Did anything happen? If you get all AQs, nothing happens. So net ionic equation, null set. Means nothing happens. So sometimes you get something happening, sometimes you don't. It's kind of like what was that movie about the special needs guy? Looking at a box of chocolate, huh? Forrest Gump, yes. Forrest was sitting on the bench with a box of chocolates. And he goes, sometimes you get something in there, and then sometimes you don't. That's my Louisiana accent, you guys. Same thing. So sometimes you get a solid, sometimes you don't. No solid, no net ionic equation. Only if the compound produces a solid, liquid, or gas. Okay, so is this starting to click? We're just setting up new combinations and seeing, yes.
The SO4, it says that salts with sulfate are usually soluble, except, so why was that an exception? Why is it Q? Oh, wait, never mind. Answer my.
The rule makes sense, all right? It's part of an exception, right?
Yeah.
Yeah.
Gotta say it out loud.
Okay, so let's try another one. Oh, and by the way, remember I said it has to be a balanced equation? Guess what's not balanced? So how many sulfates we have on the left? What about on the right? One. How about sodiums? Now we're gonna have two. What about nitrates on the left? And two on the right.
Oh, I didn't.
Right? So we have the little two there. So now it's balanced. So your test question, I'm gonna give you one of these double replacement and single replacement reactions on your test. May 1. Now, the dry lab I gave you last week has practice problems, single and double replacement reaction. It's towards the back of the test. All right, let's do another one.
That was due today or tomorrow already. The one that you gave us last week is due tomorrow. So.
Yes. It's always a week. Okay, so let's see here. I'm coming up with this stuff here. Okay, so you have sodium. Okay, so we have sodium chromate, barium nitrate. So when we do a swap now, it's going to be. So we're going to end up with sodium nitrate plus barium chromate. So here we go with sodiums again. So anything with sodium in it automatically is AQ. What about barium and chromate? Here's the chromate. And here is the barium. And it's black. So that means it forms salt. Okay, is it balanced? No. How many nitrates we have on the left? 2. We need 2 on the right. Now we have 2. Sodiums, 2 on the left, 2 on the right. Barium, have 1 on the left, 1 on the right. Chromates, 1 and 1. So now it's balanced. Yeah. Where? On the right? Yeah, S for solid. Now, whenever you see a double replacement reaction and you see something called PPT, PPT is abbreviation for precipitate. Precipitate and solids, same thing. S is easier to write, so I always write S. But sometimes you see PPT. It's short for precipitate. All right, so is there a net ionic equation? Did a solid form? Then there's a net ionic equation. So remember, this is called the, let me clean this up. So the solid, barium, chromate. How did we make that? took the barium. Plus the chromate. To get the barium chromate salt. So this is the net. Net ionic equation. And notice this is also balanced. Okay, let's try one on your arm. Let's do okay. Do that one. So remember, you're gonna swap out these guys. And see what the new combination is, and then balance it. So let me put this table up here.
But can you show me again? You show the three different types of reactions and what distinguishes them? There's molecular, there's ionic, and there's net. What's the difference? between them?
Molecular, the total ionic separates out. The molecular one, like sodium chloride are together. Total ionic, it's sodium plus chloride. It just pulls everything apart, the total ionic.
So we're not really getting, so ionic is not.
It comes,
Then what's that?
total ionic comes from the molecular. You just take everything apart. This, by definition, salts are a positive ion and a negative ion. So when you put them in water, they come apart.
Right, but generally it's not- it's not happening.
Whenever you have a double replacement reaction, you have a total ionic equation. That means you pull apart all the ionic compounds and show them separately.
So of this thing.
It's this different form of the molecular equation. It just shows everything taken apart.
So it's but it kind of be. What is happening? Right. But like for example.
Yeah.
I'm thinking of the total ionic, so that's with the pick. Elements separate or? Is that what?
with a total ionic, yeah,
Okay, and then that I got.
is if something happens. In other words, does a solid form, yes or no? If it does form, then you do the net ionic. So you pick up the,
Something new happens. When you have a new. It's considered that nothing happens.
yeah, because the water is a strong solvent and it keeps the ions apart.
So, if it's an equation. Having a double displacement.
If you have a net ionic equation, we're gonna net it out. You've heard the expression, just net it out? That means get rid of all the superfluous stuff around it. So if not, if nothing happened, everything is superfluous. Because nothing got together. And remember, the two forces, solvating force, crystal lattice force. The crystal lattice force is greater than solvating, you get a solid. Yeah,
Oh,
and back your lab packet.
Okay.
What are we supposed to do? Are we supposed to balance it and figure out if it's a solid or AQ?
And then if it's a solid, do the net ionic.
Even though the graph, the table of good.
Yeah, the rules are fine, because I use the rules to make the table.
So this is going to lead fluoride and sodium nitrate.
Mhm.
And the lead fluoride, I think it's gonna get something. And then the sodium nitrate.
Remember, sodium is never a solid. Nitrate is never a solid. So as soon as you see sodium in there, automatically no salt.
Lead fluoride.
Possible.
Well, it's because I read it here.
Yeah. That's right.
So
There
lead
there are
fluoride
three exceptions to that.
is, and I saw.
Lead, silver, mercury.
But. Right. And so then what comes next? After I've determined that there's a solid.
Then you write the solid.
We're back. Solid.
Yeah.
Well,
So you-
let me just write that as a solid.
No, you put the two together. Put lead and fluoride together. Because the rule says chemically. Okay. All right. There are three exceptions. One of them is lead. And this lead, silver, mercury. There are the three exceptions. The exceptions are the solids.
I'm gonna watch. Explain it. They're gonna go.
You know something I think is the lead is, I think we're supposed to take the chart. Right? But no, my zone, what chart the lead is.
Plus two,
But how would I know if you didn't tell me, you know what I mean?
because
Because-
it's on the ion chart that I asked you to memorize. Remember the yellow ones? Lead is one of the yellow ones.
And so, but why is?
And also look on your rule, you'll see lead plus two in it. Look at the exceptions.
If that and it.
Oh, it's gonna be, it won't be a lead three, it'll be a lead four, the other, one. There's two leads.
Oh, I see that. I mixed it up. Anyway, with lead, Yeah, so if, I know that it's not lead four, this thing's going, this is not. But. So let's say we have lead four fluoride, that would be aqueous. Wouldn't be,
Yeah, lead 4 is not on the chart.
I like beryllium.
Doesn't have the, it's not in the, it's also an exception, it's just not listed on there. It's a. More, lead 2 is more common than lead 4. So, yeah. All right. Let's do one more, and let's go to lab, and I'm concerned about your safety, because I just checked the weather, and it's still raining outside, and stuff is coming up that's gonna be, more big hail.
And yeah.
Yeah, yeah. All right, so let's put the combination together here. So that means the lead and sodium are gonna swap places, so we're gonna end up with sodium nitrate plus lead chloride. Okay, so let's balance this now. How many nitrates on the left? NO3s. Two,
Oh, yeah, I didn't see that.
It's a little too.
okay? I know, that's because I forgot to put it there. All right. So now we have two on the right also. Sodium's on the left. One on the left. Two on the right. So now we have two on the left. Chlorides. Two on the left. Two on the right. Leads. One on the left, one on the right. So now it's balanced. Okay, so sodium, it's kind of like a scratch CD. Sodium is always soluble. Nitrate, always soluble by the rules or by the table. They both show that. Okay, so that's aqueous. So just write in your notes, sodium aqueous all the time. NO3 aqueous all the time. All right, what about the lead and the chloride? What did you guys find on that? We have a vote that it's a solid. Everyone get that? Either by the rules or by the table. Now we need a net ionic equation. And when you have an external power supply, you have to plug it in. Okay, so we're gonna have a net ionic equation. And how did we make lead chloride?
Lead and chloride.
Lead and chloride. So that's the net ionic equation.
Assume that it has a charge or positive two, because lead and fluorine is so rare that it might as well not be.
Actually, it's much more common than lead 4,
I keep saying
but it's
that.
common enough to put on my common ion chart. Okay, did everyone come up with the same thing? Okay, now you're getting a lot of practice in the lab. Now your lab is going to be. Okay, on your lab today, You'll see a chart similar to this. You're not gonna be using the lamb. But. The big color, you don't need it. You're gonna have one of these laminated. And you're actually gonna do the reaction on the laminate. The droplets. And notice there's a diagonal here. And we're only gonna do the top diagonal, not the bottom. The bottom duplicates the top. So you only do one side. If you want to do two, because you're OCD, I provided for it. I said OCD. All right, that makes sense? Okay, you'll see it in the lab when you get there. And then there's dropper. And you do when you drop. Now I want you to predict first. Always predict first. Based on the rule or the chart.
Yes, it's clear. We can go. And. You have to.